Hello dear students, this is Eclax or Physics. So dear students, we are going to start a lecture series on Newton's laws of motion, which is one of the most important chapters as far as NEET or JEE mains is concerned. Okay, so Newton's laws of motion. First and foremost, what I have done is that I have divided this Newton's laws of motion into three different subchapters. Newton's laws of motion first, then NLM second and NLM third. Okay, NLM second involves friction, that includes friction, and NLM third में जो बेटा हम discuss करेंगे circular motion. Okay, so let's start with the NLM first. The first and foremost is this, the laws of motion. The topic number first जो हम discuss करेंगे बेटा, what is that? That is laws of motion. Laws of motion. All right. Now you must be knowing that there are three laws of motion: first law, second law, and third law. So one by one we'll discuss the first law of motion, then the second law of motion, and the third law of motion. Okay, so let's start with this, with the first law of motion. With the first law of motion. First law of motion. ठीक है बेटा, इसका स्टेटमेंट आपने क्लास 9th में भी पढ़ा होगा ऑलरेडी. Okay, so what the statement of the first law? The statement of first law is like this, that is, if a body is at rest, the net force on this body is equal to 0. And if a body is moving with a constant velocity, the net force on this body is also equal to 0. Okay? Or like this, a body stays at rest unless until some external force is applied on it. And a body moves with a constant velocity along a straight line unless and until some external force is applied on it. Alright? तो इसका मतलब है, इसके दो statements हैं, sub statements. Number one is this: whenever a body is at rest, whenever a body is at rest, the net force on this body that equals to 0. Alright, this is the statement number first. And number second is that whenever a body is moving with a constant velocity, when the velocity is constant, if the velocity of a body is constant, in that very case the force is also equal to 0. Okay, this is first law of motion for you. ठीक है ना? So if I want to write down this first law in the single line, what I will write down is this, that is, whenever the acceleration of the body is equal to 0, because when a body is at rest, इसकी जो velocity होती है that's equal to 0, which means that the acceleration of the body is also equal to 0. Okay, so when the acceleration of the body is equal to 0, or when velocity is constant, उस वक्त भी acceleration किसके बराबर होती है? That's equal to 0, because acceleration is rate of change of velocity. Alright, so that means whenever the acceleration of the body is equal to 0, force is equal to 0, and whenever the acceleration is not equal to 0, force is not equal to 0. This is first law, as simple as that. In single line, we can say whenever the acceleration of the body is equal to 0, the net force on that body is equal to 0. And whenever the acceleration of a body is not equal to 0, the total force or the net force on that body is not equal to 0. But there is a limitation of the Newton's first law. वो limitation ये है बेटा, that the Newton's first law ये सिर्फ हमें ये बताता है whether the force is 0 or the force is non-zero, but it will not give the magnitude of the force. For example, there is a body, its acceleration is 2 meters per second square. What will be the force on this body? That is not given by the first law of motion. First law of motion सिर्फ ये बताता है that the force is not equal to 0 or it is equal to 0. Alright, that's the limitation of the first law. Okay, so this is first law. Moreover, what I will write down here is this, जो ये first law है, first law, point number first is that defines force. It defines force. What we mean by that? First law सिर्फ आपको ये देगा whether there is force on the body or there is no net force on the body. Number one. Number second is that वो भी आपको पता होना चाहिए that this first law is also called as law of inertia. Also called as law of inertia. Law of inertia. It's also called as law of inertia. Okay, so that is enough about the first law of motion. Straight away, let's go to the second law, which is very, very important. Okay, so let's switch the second law of motion. तो यहाँ पर मैं लिखूंगा बेटा न्यूटन सेकंड लॉ ऑफ मोशन. न्यूटन सेकंड लॉ ऑफ मोशन, which is very important, very, very important. ठीक है ना? Before discussing Newton's second law of motion, I'll give a brief idea about the momentum. Linear momentum होता क्या है? Okay, so let me write down here linear momentum. I'll write down here linear momentum. All right, linear momentum denoted by P. It's a vector quantity. Okay, so how we define linear momentum? There are two definitions of the linear momentum. Definition number one is this: It is defined as the total motion possessed by a body, number one. And number second definition is that it is defined as the product of mass of the body and the velocity of the body. Okay, so let me write down the definition number second. That is, for example, हमारे पास एक object है बेटा, this is a ball, and the mass of this ball is equal to m. It's moving with some velocity which is equal to v. All right, v towards right. Okay, then the momentum of this object is defined like this by this equation: p equals to m multiplied by v. Okay, while this m is what? It is the mass of the object. And what about this v? This v is the velocity of the object. Okay, now next point is this: is this momentum a scalar quantity or a vector quantity? Okay, the answer is obvious, it's a vector quantity. And what about the direction of the momentum? That will be obviously parallel to the velocity. If the velocity is towards right, the momentum will be towards right. If the velocity is towards left, the momentum will be towards left, and so on and so forth. So what I will write down is this: this momentum is a vector quantity and it's always parallel to velocity. ठीक है बेटा? Okay, it's always parallel to velocity. ठीक? One more thing about the momentum you must know is that what are the units and dimensions of momentum? What is the SI unit of momentum and what will be the dimensional formula of momentum? Let me write it here. यहाँ मैं लिखूंगा बेटा SI unit of momentum. ठीक? Okay, momentum किसके बराबर है बेटा? It's equal to mass into velocity. What is the SI unit of mass? You know that is kilogram. And what will be the SI unit of velocity? That is meter per second. So that means the SI unit of momentum is kilogram meter per second. All right. And from there you can tell what will be the dimensional formula of momentum, and what is that? That is m1 l1 t minus 1. m1 l1 t minus 1. Okay, so this information as of now is enough about the momentum. Okay, now why we are going to discuss the momentum here? The reason is that जब आप न्यूटन सेकंड लॉ का स्टेटमेंट पढ़ोगे, that will be like this: the force is directly proportional to rate of change of momentum with respect to time. So that's why आपको पहले momentum का आइडिया होना चाहिए. तो नेक्स्ट देख लीजिए बेटा, नेक्स्ट. ओके, नेक्स्ट हम क्या लिखेंगे? द स्टेटमेंट ऑफ द न्यूटन्स सेकंड लॉ ऑफ मोशन. व्हाट इज द स्टेटमेंट ऑफ न्यूटन सेकंड लॉ ऑफ मोशन? ओके, तो इसका स्टेटमेंट ये है that the net force on an object is equal to a rate of change of momentum with respect to time. Okay, that is the statement. Like this it is simply: force equals to rate of change of momentum denoted by dp divided by dt. Differentiation of momentum with respect to time will give what? That will give momentum. This is our equation number first. Okay, तो यही मैं बोल रहा था आपको, जो ये न्यूटन फर्स्ट लॉ है ये आपको सिर्फ बताएगा whether there is force on an object or there is no force on the object. Okay, Newton's second law gives you exactly what is the magnitude of that force, and that is how Newton's second law is superior over the Newton's first law of motion. Okay, so momentum, let me play with this mathematical equation. यहाँ पे हम क्या लिख सकते हैं बेटा? This p we can replace it by mass into velocity. Alright, तो देख लो बेटा ये इक्वेशन क्या बन जाएगी? This is F equals to d by dt of what I will write down is mass into velocity. सही है बेटा? Okay, momentum के बदले मैंने क्या रिप्लेस किया? Mass into velocity. Now what I can do here is this: I can use UV rule, product rule, in the differentiation. Okay, so differentiation of u into v is u into differentiation of v plus v into differentiation of u, or keep the first function as such and differentiate the second function, plus keep the second function as such and differentiate the first function. That is what I am going to do. So concentrate here. F equals to, keep the first function as such, m into dv divided by dt plus what? Plus velocity v into dm by dt. Okay, सही है बेटा? Where m is mass and v is velocity. What is this dv by dt? It is rate of change of velocity with respect to time. And you must know from the kinematics that the rate of change of velocity with respect to time gives acceleration. So dv by dt is what? It is essentially acceleration, number one. Number second is this dm by dt. What is it? It is the rate of change of mass with respect to time. So we have one more equation here, that is F equals to m multiplied by acceleration a plus v into dm divided by dt. This is our equation number second. Equation number first is Newton's second law of motion. Equation number second is Newton's second law of motion. Okay, the simple reason is that equation number 2 we have derived that, वो हमने कहाँ से derive की? From the equation number first. All right, अब ये dm by dt है क्या बेटा? It is actually rate of change of mass with respect to time. Okay, but in NLM or in mechanics in general, there will be most of the problems wherein जहाँ पे जो ये mass है it will remain constant. इसका मतलब क्या है? For example, a car it starts from point A to point B. Point A पे इसका mass है 1000 किलोग्राम, point B पे इसका mass है 1000 किलोग्राम, so the mass remains constant. Okay, but is it that क्या कोई problem है mechanics में जहाँ पे ये mass variable हैं? The answer is yes. There are some problems where the mass will remain constant, and there are some problems, very few problems, where the mass is variable. Okay, and which problem is that? There's a problem that's called a rocket propulsion problem. Okay, for example, imagine like this. अब imagine कर लो बेटा, एक rocket जा रहा है from the surface of Earth into the space. When it goes from the surface of Earth into the space, the mass will not remain constant. The reason is that इसका जो ज़्यादा mass होता है, a big proportion of mass, that is fuel. Okay, and when it goes from the earth to the space, the fuel continuously burns out, so as a result of which its mass continuously decreases. तो इसका मतलब जो वहाँ पे dm/dt होगा, rate of change of mass with respect time, that will be non-zero, that will be not equal to zero. Okay, but in like 95% of the problems the mass remains constant. Okay, so we will have one more equation, and that will be a special case, and that's like this. I will write here, if mass of the object is equal to constant, if mass of the object is equal to constant, which is true in case of 90 or 95% of the problems in the mechanics. तो इसका मतलब क्या है? This implies that this dm/dt, you know that differentiation of a constant is equal to 0. तो ये dm/dt किसके बराबर बनेगा? 0. So we have one more equation, one beautiful equation, f equal to m into a, which is our equation number 3rd. ये है बेटा हमारी पास equation number 3rd. लेकिन जो equation number 3rd है, it is not a generalized equation. It is true only if mass remains constant. If the mass varies, in that very case, this equation fails. This equation is not true. So equation number 2nd is a more generalized equation, and equation number 3rd is the special case of equation number 2. All right. Okay. So what I will do next is that I will summarize these equations. So the three equations here are like this: F equals to dp divided by dt, which is rate of change of momentum with respect to t. This is our equation number 1st. Equation number 2nd जो हमारे पास है बेटा, that is equal to this, that is m multiplied by a plus v into dm/dt, which is equivalent to the equation number 1st, because we have derived this from the equation number 1st. Then there is one more equation, f equals to m into a. This is our equation number 3rd, but this equation is true only if mass is constant. Okay, so this is the summary of Newton's laws of motion, Newton's second law of motion rather. Okay, so here we'll be back to these equations. We'll get back to these equations in a while. In the meantime, we'll discuss some basic terms, like हमें ये पता होना चाहिए what is an impulsive force, number 1. Number 2nd, हमें ये पता होना चाहिए what is impulse momentum theorem, okay, and what is the impulse of a force, ये भी हमें पता होना चाहिए. Okay, so let's discuss these one by one. These are small definitions. Okay, so let's switch to that. हाँ, तो क्या मैं बोल रहा था बेटा? So मैं ये बोल रहा था बेटा, we must discuss what we mean by impulse, number 1. Number 2nd, what is an impulsive force? होता क्या है impulsive force? Number 3rd is that we must discuss here what we call as impulse momentum theorem. Impulse momentum theorem. Okay, so these are three basic definitions: impulse, impulsive force, and impulse momentum theorem. Okay, तो सबसे पहले कहाँ से start करेंगे? Let's start from A, and that is impulsive force. Let's start from here, impulsive force. Let's start from impulsive force. Okay, देख लो बेटा, in our nature there are different types of forces. One such type of force is called as impulsive force. अब ये होता क्या है impulsive force? Impulsive force is defined like this: it is that force whose magnitude is very large. Magnitude is very large, number 1. Number 2nd is that but it spans, it lasts, or it exists for very small time. That's how we define impulsive force. Sir, are there any examples of the impulsive force? Yes beta, there are some examples of the impulsive force. Like, for example, a cricketer is there, he is hitting the cricket ball. The moment he hits the cricket ball, the force applied by the bat on the ball is very huge, but that force lasts for a very small time, so such a force is called impulsive force. Okay, suppose Ronaldo, he kicks the football. When he kicks the football, the force applied by the foot on the ball is very huge, but that force, that impact, that lasts for a very small time. again an impulsive force. Explosion problem, explosion, that's what an impulsive force. Huge force applied on the shells of the explosion, on the shell, but that lasts for very small time. Okay, then collision between two billiard balls or collision between two carom coins, that's also an impulsive force. Huge force but lasts for very small time. So those forces are called what? They are called as impulsive forces. So how we define impulsive force? So impulsive force is that whose magnitude is very large. Magnitude is very large. Whose magnitude is very large. Okay, but time, they last for time delta t is very small. They last for very small time. Okay, delta t is very small. Such force are called what? Impulsive force. Examples तो मैंने आपको बताई है, ठीक है ना? Okay. Next B is point number B is what? Impulsive force हो गया. तो impulse क्या होता है बेटा? How we define impulse of a force? How we define impulse of a force? It's a vector quantity denoted by I. ठीक है बेटा? So how we define impulse? Impulse is defined as the product of force and the time for which it acts. Simple. So impulse is defined what? It is defined as the product of the force and the time for which it lasts. F into delta t, or rather we can say F average into delta t. That's how we define the impulse. Okay, simple. Next क्या है बेटा? Next है what is impulse momentum theorem. Impulse momentum theorem. Impulse momentum theorem. Okay. Impulse momentum theorem का simple सा statement ये है that the impulse of a force is equal to change in momentum of the object on which the impulsive force acts. Okay, so simply it's like this. It's simply like this, that the impulse of a force is equal to delta p, that is change in momentum. Simple सी बात है, it's equal to change in momentum. Okay, can we prove it? Yes, we can prove it with no time. तो पहले first of all what you will do is this, impulse किसके बराबर है बेटा? That's equal to average force multiplied by delta t. Is that okay with you? Average force multiplied by delta t. All right. अब force Newton's second law, that is equal instantaneous force जो है, that is dp by dt. Okay. Average force can be written like this. It is equal to delta p divided by delta t. This Newton's second law multiplied by what? Delta t. Easily what we can do is that delta t and delta t goes, and we are left with this equation, that is this impulse is equal to delta p. Okay, so it is the simplest proof of this impulse momentum theorem. All right, ठीक है बेटा? Okay, so यहाँ से आपको what are the important equations from here? What are the important equations? Simple. Equation number first is what is this impulse equal to? That's equal to average force multiplied by delta t, and which is in turn equal to delta p. That is as simple as that. Okay, just highlight this single equation. That's important for us. Okay, so I'm sure आपको अच्छे से समझ में आया होगा what is impulsive force. So that force whose magnitude is very large but lasts for very small time. Such a force is called impulsive force. Number one. Number second is that what we mean by impulse, it is defined as the product of force and the time for which it acts. Then number third is that what we mean by impulse momentum theorem. It is simply like this, that the impulse of a force is equal to change in momentum of an object, which simply by simple derivation, mathematical derivation, we have derived this. Okay. So we are done with Newton's second law of motion. We are done with this impulse, with the concept of impulse. Okay. Next, I will write down some mathematical equations, okay, for the Newton's second law of motion, and then what we'll do next is that we'll do the examples on the Newton's second law of motion. Okay. So let me do that. Let me do that. Okay. So here I will write down. What I will write down is this. Number one is that instantaneous force. Number one is that instantaneous force. It's a bit similar to the kinematics, this topic, instantaneous force. Okay, the instantaneous force means what? It means force at an instant of time. For example, there is an object right now, the force on the object is equal to 10 Newton. This 10 Newton is the instantaneous force. Right now, at this moment, what is the force on the object? That's called instantaneous force, and it is given by this F equal to dp divided by dt, which is rate of change of momentum with respect to time. Okay, and you must know, आपको एक concept पता होना चाहिए, that is from the differentiation, that is the differentiation gives slope of a curve at a point, and slope is in turn given by tan theta. So let me write it here. It's equal to tan theta, or tan theta means what? It means slope. अब इसका मतलब क्या है, दैट f is equal to dp by dt and is equal to tan theta. This means if you have momentum versus time curve, a momentum versus time graph, the slope of that graph will give the instantaneous force at any instant of time. Okay, it will be clear with the help of examples. So number one. Number second is that you must know what is average force. Average force. Okay, so average force जो है, instantaneous force, it is defined at a moment of time. Defined at an instant or moment of time. And average force is always defined over an interval of time. Interval of time. थोड़ा सा कॉन्सेप्ट आपको होगा एवरेज वेलोसिटी और इंस्टेंटेनियस वेलोसिटी का. So average force defined over an interval of time like this. Calculate the force on the object between t equal to 0 and t equal to 3 seconds. This 0 and 3 seconds is an interval of time. Calculate the force at t equal to 4 seconds, that's an instant of time. So average force, अब ये किसके बराबर होता है? It is equal to delta p divided by delta t. What is this delta p? Delta p is a finite change in momentum. And what is this delta t? It is a change in time. Okay, what does that mean? That means delta p can be written like this. It is final momentum minus initial momentum divided by final time minus initial time. So this equation gives you what? It gives you average force. Alright, so instantaneous force, and then next is average force. Next there is one more important, and that is change in momentum or impulse. Change in momentum or impulse. Change in momentum or impulse, because you know that impulse is equal to what? That is change in momentum or impulse. तो यहाँ पर मैं लिखूंगा बेटा I is equal to delta p. सही है? ओके, देख लो बेटा, what is Newton's second law of motion? That is simply like this. It is F equals to dp divided by dt. Easily we can write down like this. This dp is equal to F dt. Okay, what is this dp? It's a very small change, a vanishingly small change in momentum. Dt, a very small change in time. Now what I will do next is that I will integrate both sides. Integration of dp, integration of f dt. Alright, lower limit is p1, upper limit is p2. Initial momentum, final momentum, t1, t2. ठीक है बेटा, integration of dp, that is simply equal to p, then final momentum minus initial momentum, तो बनेगा बेटा delta p. And this is equal to integration of f into dt. Limits are t1 to t2. Okay? अब यहाँ पे एक कॉन्सेप्ट और आपको पता होना चाहिए, that is the area under a curve is given by the integration, or integration gives area under a curve. So that means here I will write this is equal to area under the curve. Okay? तो इस एरिया का मतलब क्या है बेटा? इस एरिया का मतलब ये है, that means suppose that you have f versus t graph. The area under the f versus t graph will give what? That will give change in momentum. Alright, so we have three important equations. Number first is this instantaneous force. Number second is this which gives average force. And number third is this delta p. And what is this delta p? The change in momentum, or it is in turn equal to impulse. It's in turn equal to impulse. Okay, alright, ठीक है बेटा. तो यहाँ तक आई एम श्योर आपको अच्छे से समझ में आया होगा न्यूटन्स फर्स्ट लॉ ऑफ मोशन एंड देन द न्यूटन्स सेकंड लॉ ऑफ मोशन. ओके, यहाँ पे एक छोटा सा कॉन्सेप्ट है, दैट इज what are the units and dimensions of force. Before going into the problems, deep in the problems, we'll discuss what is the SI unit of force, what is the CGS unit of force, and what is the dimensional formula of force. Okay, let me discuss that one by one. Alright, तो देख लो बेटा, next is what? Next हमारे पास यहाँ जो टॉपिक है, that is units and dimensions. Units and dimensions of force. Units and dimensions of force. Alright, okay. First of all, the units of force, they are classified in two categories. One we call as absolute units, and second we call as gravitational units. Okay, so let me discuss one by one. First of all, absolute units. Absolute units. ठीक है बेटा, absolute units. So you must know SI unit of force. ये तो आपको पता ही होना चाहिए. SI unit of force. बोलो बेटा क्या होता है SI unit of force? Is what? That is without a doubt, that's Newton. ओके, एंड न्यूटन किसके बराबर होता है? दैट इज किलोग्राम मीटर पर सेकंड स्क्वायर. सिंपली मास इनटू एक्सेलरेशन. मास का ऐसा यूनिट है किलोग्राम, एक्सेलरेशन का मीटर पर सेकंड स्क्वायर. ऑलराइट, देन द सीजीएस यूनिट. सीजीएस यूनिट. of what a force is, that is dyne. That is dyne. And dyne is what? That is gram centimeter per second square. ठीक है बेटा, सही है. Okay. Is there a relation between the Newton and dyne? Yes, there is, of course, and that is 1 Newton is equal to 10 raised to power 5 dyne. This equation is used to convert the force from the dyne into the Newton or from Newton into the dyne, depending upon your convenience. Okay. So next जो है बेटा, next there is one more type of units, and that's what we call as gravitational units. Gravitational units. Absolute units, there are two. Number one SI, number second CGS. SI unit is what? Newton. CGS unit is what? Dyne. 1 Newton is 10 raised to power 5 dyne. Alright. Okay. Now here we have again SI units and CGS units. SI, CGS. Okay. So what is the SI unit of force in the gravitational units? That is kilogram force. What's that? That is kilogram force, denoted by kgf. Kilogram force. And what is the CGS unit? That is gram force. Okay. अब होता क्या है ये? What is this kilogram force? What is this kilogram force? Kilogram force is simply, it is the gravitational force on an object whose mass is 1 kg. So what's it? Or I will say like this, it is the weight of, as simple as that, weight of 1 kg. Weight of 1 kg. And what is this gram force? It is the weight or the gravitational force of 1 gram. 1 gram, as simple as that. यहाँ पे ध्यान रखो बेटा. Suppose that here we have, this is a block. The mass of this block is equal to 1 kilogram. इसका जो weight होगा, that will be equal to m multiplied by g. Acceleration due to gravity, you know that that's equal to 9.8 meter per second square. तो ये क्या बनेगा बेटा? 1 into 9.8, that's equal to 9.8 Newton. And this 9.8 Newton is defined as 1 kgf, 1 kilogram force. An important equation. 9.8 Newton is equal to 1 kilogram force. So that means this 1 kgf, it's equal to what? 9.8 Newton. All right. Another point. What is this gram force? ये आप एक ब्लॉक ले लो बेटा. इसका जो मास है, let's suppose it is 1 gram. हाँ, तो इसका जो weight होगा, weight will be equal to m multiplied by g. Okay. What is the value of this m? That is 1 gram. What is the value of acceleration due to gravity? 9.8 meter per second square, or we can say 980 centimeter per second square. ठीक. तो ये बनेगा बेटा 1 into 980, that is 980, and it will be dyne. CGS unit, dyne. And this 980, it is 1 gram force. So another important equation, that is 1 gram force is equal to 980 dyne. Okay. So simple points. Number one, what is the SI unit of the force? Newton. What is the CGS unit of force? Dyne. 1 Newton is how many dyne? 10 raised to the power 5 dyne. Then the gravitational units. What is the SI unit? Kilogram force. What is the CGS unit? Gram force. 1 kilogram force is how many Newton? 9.8 Newton, or approximately 10 Newton. How many? 1 gram force is how many dyne? That is 980 dyne, or approximately 1000 dyne. Okay. So this is a brief idea about the units and dimensions of force. Okay. Then there is one last point, and that is what is the dimensional formula. ये भी आपको पता होना चाहिए. Dimensional formula of force होता किसके बराबर है? Okay. तो इसका unit क्या है बेटा? That's Newton or kilogram meter per second square. So what will be the dimensional formula? That will be m1 L1 t minus 2. That's it. Okay. So in this very lecture, in this very session, what we have discussed is number one, what's the Newton's first law? So Newton's first law in the one line is simply, if the acceleration is equal to 0, force is 0. If the acceleration is not equal to 0, force is not equal to 0. Then we have discussed in detail what is Newton's second law of motion. Okay? Let's have a quick recap of all this. So first of all, this is Newton's first law of motion. We have discussed this in detail. The next is this. This is linear momentum we have discussed, which is mass into velocity, units and dimensions. And the next we have discussed what? The Newton's second law of motion, and here we have summarized all the three equations. All the three equations, very important equations. We are yet to do the examples on this. अभी तक हमने इस पे examples नहीं की हैं बेटा. The next is this, what impulse क्या होता है? Impulsive force क्या होता है? और impulse momentum theorem. That is simply like this: impulse is equal to F into delta t, force and the time is equal to delta p, change in momentum. Then we have discussed this instantaneous force, which equals to dp by dt, average force delta p by delta t, then delta p, that's equal to this. All right. And then we have discussed at the end what this units and dimensions of the force. Okay. So this was our lecture number first on NLM. See you with the lecture number second. Okay, take care.